Oh, okay. So we're excited to share a couple different things with you. We just have an hour, so it is going to be a little bit on the fast-paced side, but we're going to try to keep a bit of time at the end if there are any questions. I guess I'll be kicking it off, and really what I want to start off with is just a quick primer on AI. It'll be very short, just getting you familiarized with some of the concepts just to level set. A lot of the examples I'm going to talk about today are going to be more healthcare oriented, but by no means is AI just in that space, and we can talk about other use cases if people are interested as well. So, getting started, and many people, and I would say the average population really thinks about AI in this sense. They look at Hollywood and they think, okay, well, it's some sort of generalized intelligence that's doing things and it's go off on its own and it's being autonomous. Some of them are positive, some of them are negative, and some of them are, let's say, morally ambiguous. That's not necessarily what we're talking about today. While this is a nice little dream for the future, really what we're talking about when it comes to AI is more of this. A lot of apps that you may be utilizing today that leverage artificial intelligence and machine learning in some way. Sounds like someone may have put us on hold. Okay. And really what you can think about these solutions is applied mathematics. They're really just taking data, they're trying to figure out how do you make sense of it and come up with predictions.
Hello, can you guys hear me?
I can hear you. I was just going to say, was it just me or is he gone?
Yeah, I think we lost him. Oh, there we go.
Oh, there we go.
We're here. Sorry. Good. I think we were hearing the beeps
and we thought someone put us on hold. So.
Yeah, there was that was my fault. My apologies. I was trying to find the beeping, which I muted. So 647-354-1006. You've been muted, and email me if you want to be unmuted.
So I guess start from the top. I don't know where you guys lost us.
Just a minute, just the last sentence. So yeah, please continue.
Okay, yeah. So really, where we are is more AI in this sense. So they're narrow applications of AI, and they're things that impact your life in many different ways. And it's effectively just applied mathematics. We're taking data, we're trying to make some sort of sense of it, and trying to come up with predictions, whether it be through images, through text, through voice, or through structured data. So when it comes to things like Netflix and Amazon and Spotify, what they're looking for is how do I recommend things based off of who you are as a person and the different attributes of the products or services that you're consuming. Obviously, things like Tesla are trying to perceive the world and act in a space to drive your car and keep you safe. And then Facebook is trying to do a whole bunch of different things as are Google in these areas. And there are many different aspects of artificial intelligence and machine learning that you utilize in your day-to-day life that you may not necessarily know. Even things like keeping your mobile networks as efficient as possible. There's a lot that goes on in the background. So there's a lot that can be said about the history of AI, and this is one timeline of it, and I would say a little bit more of an IBM-centric version of it. And for us, it started way back when, probably around in 1956, where there was something called the Dartmouth Conference, and this was a collection of professors from Dartmouth, as well as Carnegie Mellon, Stanford, MIT, a few other universities, as well as IBM. And they're really trying to determine what it means to develop an artificial intelligence and codified the terminology that was previously mentioned by I guess, some of our first computer scientists. Over time, we've had development in that space, and as well as a few different things that people have called AI winters, where progress really didn't grow. And very recently, we start to see a real increase in the application of AI and success in this space. And there's a couple different points that explain that. One is data and compute power, as well as different methodologies. So in 2011, we had our second grand challenge, our first being the chess with Garry Kasparov in 1997. But in 2011, Watson was put onto Jeopardy, where it won a 2-day bout against Ken Jennings and Brad Rutter. This was an impressive engineering task that demonstrated that we can now start to understand language through computers in a more natural way and answer questions that are massive at scale. And that really prompted IBM's focus to start applying some of these technologies in other spaces. So healthcare is a really large one. So the Cleveland Clinic, Memorial Sloan Kettering, the Mayo Clinic, we've been working with them on various different applications. And all of these providers, as well as universities, are now really working in the healthcare space with other providers as well, identifying things like cancer detection. And I'll talk about that briefly as well. Now, we come to today, and we've already started thinking about different challenges, applications of quantum computing in healthcare as well as in combination with machine learning. We have another great challenge called Project Debater, which is more about how do you formulate arguments and have a debate with machine in a way that has structured conversation. And various other providers around the world are tackling different problems, whether it be computer vision, reinforcement learning, structured learning, and otherwise. So as I mentioned, data is really core to why we've seen this explosion. Majority of our data in the past used to be structured in nature. And when I say structured, I'm talking about things that can be put into a table. But really what we're finding, and by next year, we'll find that the vast majority of our data will be unstructured in nature, and that'll continue to grow rapidly. So there's a lot of insights that need to be earned from devices and sensors, medical imaging, natural language text, other images. And in order to capture that insight, you need a few different applications or methodologies that stray away from traditional machine learning algorithms of the past and move more into reinforcement learning as well as deep learning tasks. So some of the use cases that you can think of and that I've mentioned already, things like recommendation engines, natural language processing, predictive analytics, image analytics. These are all different ways that you can utilize AI. And then another area that I am not going to really talk about a whole lot today is reinforcement learning, where right now it's been an interesting application to play video games and board games, but it'll be interesting to see how AI that acts as an agent and learns from experiences can be applied in other areas as well. So when it comes to AI, there's a lot of benefit that it can do. It can take in unstructured data and provide you insights. It can provide you predictions, and it can prove outcomes. But there are ethical considerations that you need to keep in mind. And I really want to talk about three stories that outline the ethics, the impact of AI in three different ways. So the first one is breast cancer detection. As early as about a year and a half ago, we were starting to find that there are some algorithms that are better than the average radiologist at identifying breast cancer through high quality, high resolution scans. So the caveat being there, the high quality, high resolution, where not all data may be available in that state, but it's definitely a promising outcome. So we're seeing that the application of AI from an ethics perspective is a positive one, in the sense that it's improving outcomes for patients and it's improving outcomes for healthcare providers, and that can be seen extremely positively. The middle example is about Dave Ferrucci's father, and many of you are probably thinking, well, who is David Ferrucci? And that's a reasonable question. So David Ferrucci was the lead engineer who led the development of Watson for the Jeopardy challenge back in 2011. His father earlier in his life had a heart attack that put him into a coma. The doctors, after looking through his case, came to the conclusion that given his state, the likelihood of him being brain dead and not coming out of it was extremely high, and as a result suggested to David that he should sign a do not resuscitate form. Now David, talking to the doctor, asked, well, I understand the statistics, but how do you know that my father will not come out of this coma? To which the doctor's response is, well, looking at the data, the likelihood and the frequency in which we've seen these similar cases, that's just been what has happened majority of the time. Now, the unfortunate truth is that David did not sign that do not resuscitate. A few days later, Dave Ferrucci's father was awake and with very little to no brain damage presenting after that fact. So here's a scenario where a human failed to make the right decision, but I would say that the AI would have made the same kind of decision. It's a statistical solution that is looking at data, it's looking at previous instances and saying, how do I predict what the future outcome of this scenario is? And in all likelihood, it probably would have said the same thing. And that says a lot about the way that we tackle problems. It's not just about statistics, especially when it comes to an individual person. You have to think about, how do I know the determinism? Am I playing with the emotions of this scenario? Am I realizing that this is a person's father? And they're not interested in just hearing statistics. They want to know why exactly and what is the cause. And AI doesn't necessarily give you causes, it gives you likelihoods. It's focused on the chance that something can happen. So this is an area where AI and humans both were somewhat fallible in this case. But then I'll talk about the last example, which is pacemakers in pregnancy. A lot of pacemakers nowadays are being trained in a way where they're taking data and they're trying to understand whether or not some form of time series data, so heartbeats, demonstrates an issue which requires the pacemaker to intervene. The problem is many pacemaker developers haven't thought about including the data sets of pregnant women in this case. There was a case a few years ago where a woman who was near the end of her pregnancy had some sort of heart anomalies occurring because of the pregnancy. As a result, her pacemaker that was installed for a previous issue kicked in and causing issues that could have threatened and harmed her as well as the unborn child. So this is a scenario where the developers of AI or the developers of any sort of algorithm need to consider all of their end users. They need to make sure that their data is not biased in a way that excludes someone that could result in poor outcomes. So hopefully those three stories in a bit more of a medical format outline three different ways to think about AI. It can improve your outcomes for patients, or it can improve outcomes for any user. It could fail just in the same way that a human can fail. And then in the case of biases in your data, it can definitely fail because it doesn't have the experience, it hasn't learned from a wide data set that represents your overall population. So hopefully that was a quick and dirty introduction to AI and some of its ethical impacts. But now I want to swap the conversation and be more focused on dialogue systems. So my area of expertise is around natural language processing. Dialogue systems have many different words. You've probably heard chatbots or chatterbots or virtual assistants or virtual advisors. They're really any sort of system that's somewhat like your Google Home or Alexa or Siri, something that you can communicate with both in text as well as in voice, and get an answer through some sort of messaging platform. So the use cases for something like this are predominantly threefold. The first one is customer care, so providing an end user with information that allows them to solve their problems or to self-service themselves. The middle one is around employee productivity, so how can you utilize a chatbot to give insights and information and standardized policies and procedures to your employees so they can speed up the way that they're working. A common use of this is HR and IT help desk. And the next one is just conversational user interfaces. So for any user, how can I, through voice, interact with some sort of information or a device in a way that improves my efficiency without requiring my hands or text? So how do these chatbots work? Well, the first thing that you do is you create intents. You classify a bunch of questions that are similar. So you're taking end-user representative utterances that can come from chat logs or from your own intuition or previous conversations, and you're saying that they group together as a similar sentiment. So in this case, we have a few questions about resetting a password. So we have some people who have mentioned that they've forgotten a password, some people saying that they need to reset a password, some people who are just saying that they can't log into the website. And to us, they all seem to suggest that the same kind of intent, that here is a person who wants to reset a password. Once I take that intent, when I see brand new questions, I can extract that information. So in this case, I see a question that says, I've been frustrated, I haven't been able to log into the online billing system. We've identified that this is clearly a password reset. This is a question that Watson has never seen before, but it's identifying the same kind of intent. The next thing it'll do is identify entities. So entities are typically nouns. They're terminology that are either unique to your use case or commonly utilized. So in this case, it's an online billing system. We're clarifying that the password that is being reset is for the online billing system and not your email, not your computer, and that's guiding what we're going to be providing answers for. The next thing you may want to do is understand someone's emotion and their tone. In this case, this person is clearly frustrated. We're leveraging some sort of sentiment analysis. And we may choose to utilize that information to change the way we respond, either by having a more sympathetic tone or saying that maybe a chatbot is not the appropriate methodology to contact this person. We should escalate them and get them in contact with a live human being. And then finally, we're bringing in any other context we know about them. So this is context that has come from other messages in the conversation. So we may know that they're Bill Smith, they're 47 years old and a gold member. And other context we may have is being loaded in from other data sources. So in this case, we may know that they're contacting us from a mobile phone, and as a result, we may choose to escalate to a live agent because this is an angry, high-value customer, and they're already on a medium that is suitable for having a call. So once you have all those pieces of information, it moves into the aspect of dialogue. So dialogue is really the way we build out our user experiences. So in the case that someone says, I want to reset a password, the approach might be to guide a person through the steps one by one. But dialogue doesn't necessarily need to be a text response. It's really just any action that determines the outcome. So you may choose to deflect, which is transferring to a human agent. You may ask for a map, and you can populate a map or show them how to navigate within an application. We may choose to pull up documents that have the right answer. Or we may try to call an API that is an algorithm that suggests the next best action. So really what you do is you classify that initial question, you understand what the meaning of the question and what a user wants, and then you come up with an action that you can do that's going to provide them with the best user experience. So this is one of the areas where AI and user experience design really start to meld together, because it's all about creating the customer experience for them. And there's considerations in terms of the way you write your copywriting, the way you write your flows, and when you're going to escalate and deal with a human being for when the bot starts to fail. So now I'm just going to show you a quick demo of what one of these bots can look like. And I guess I'm going to have to figure out how to swap my screen. So I'm going to stop presenting and share my screen again. In the meantime, any questions on what we've talked about so far?
Hey, sorry, Jeff Russell. Do you have a couple just minor questions? So at the beginning, we're talking about basically we're just aggregating data, right? And so it's knowing the right data to aggregate before we aggregate it. So really, there's two layers to the AI where you need to make sure you have the right data before you start doing that aggregation. Is that what we're? I mean, that's the nutshell for AI.
Yeah, well, data is always a major component of any AI system. The better your data and the better that it is organized, the better your solution is going to be. So when it comes to the chatbot, that first step of grouping those things together, that task has many different ways that you can do that task, and you can group things together in any way you want. But thinking about the best way from the perspective of a user experience is where you're going to see a lot of impact or positive impact, as well as thinking about the impact that it's going to have on the quality of the classifier and its understanding. So there's a technical understanding, there's a user experience understanding that goes into this task.
Right. So and then that part is just commonality. So there's like you're looking for the word login or password and grouping those based on those commonalities. Is that correct?
Yeah, exactly. And now, in the past, a lot of this task when it comes to chatbots had to be done by hand, and I would say many platforms continue to require you to do that, which is understandably time-consuming. So our Watson Assistant platform is also one of the only platforms where we utilize AI to train the AI. So we try to pre-cluster things for you based off of what we see as a recommendation and a suggestion on how you should create your intents. And then you as the administrator have the task of agreeing or disagreeing and accepting those changes and making adjustments. So as it starts to learn how you want to cluster, it keeps updating its approach. So it's always helping you get the right answer or better training on an ongoing basis. So it really removes that hand-driven task of the past of grouping things together in a large Excel document, for example.
Right. And so you're just verifying if it's saying, hey, we think when they're doing this, they want X. If when they say, and so you're just building up that library of commonalities to nail it down to what you think the caller intent would be or the message intent would be.
Yeah, exactly.
Right. And then, I lost my other train. Carry on. It might come back. Sorry.
Sure, no problem. And so right now I'm going to show you a very short demo. This is the versusarthritis.org. So they're an organization in the UK. This is a purely informational bot, and it's really driven to help users who are struggling with arthritis and need a little bit more information. So I'll get started. And the first thing it's going to ask is my name. So that way it can reference me throughout the conversation, and it just seems a little bit more personable. And then it's asking me what kind of condition I have. And I'm just going to type in RA. Now, in the domain of arthritis, this makes a whole lot of sense. It stands for rheumatoid arthritis. But in other domains, it doesn't necessarily have a lot of meaning. So this is a system that was built as an expert system, one that understands the domain and provide data specifically around that domain for the type of user who's going to utilize it. So now that it knows that I have rheumatoid arthritis, it's going to ask me a question. So, I may say, what is RA? I don't necessarily have to type rheumatoid arthritis ever. And it'll give me a definition for what that is. And then I may say something like, what are the treatment options?
I don't think we can see your screen.
You can't see my screen? Oh, no.
Okay. No, it's got that. It's the Skype interfaces on the front. Can you move that chatbot to the left of your screen?
Here,
if you drag the people that are speaking to the top right, you can drag that at least in Skype as well. So that's another approach. Yeah.
Any better now? Still?
I think the prior. I would just do basically what you did, and the people that are using Skype can move the people that are speaking to a different angle. This also works. Sure.
That works? All right. It's not like the rest of the website matters a whole lot anyway. So in this case, I said, what are the treatment options? And the important thing to note is we always want to design conversations that are contextual in nature, so they sound more human. In this case, I'm not asking for the treatment options for rheumatoid arthritis specifically, but it knows that is the context of the conversation and doesn't need it specified. If I hadn't earlier mentioned rheumatoid arthritis, it would do a task called disambiguation. Effectively, it's trying to understand what do you want to know the treatment options for. In this case, I can jump directly to an answer, and it's saying, well, there's a few different treatment options. You want to learn a little bit more about drugs or therapy. We create buttons that will help guide a user to get to an answer quicker, knowing that they're likely going to be the types of responses they're going to provide. So if I say drugs, it'll provide me a little bit more about them, and I can pick and go a little bit deeper there as well. Then finally, I may say something like, I've been having some pain. Should I go to the hospital? Hospital. So now it's coming up and telling you, well, aches and pains are common. Sometimes they may be caused by unusual strain. You should typically go see your doctor if you have these particular symptoms. If you have any issues, you can call this number. So especially where today a lot of our waiting rooms are filled up, especially in our emergency rooms are filled up with people who don't necessarily need to be there, this becomes a resource to inform the consumer and let them know when they should or should not go without having to call, I'm trying to remember what the number is for the nurses, 411? At least in Ontario, I think that's what it is. So this is just a purely informational use case, but you can start to think, well, where does this go from here? How do you evolve this? Can I start collecting some of their information that would be utilized for an intake form? So while a person is on the way to the hospital or to the clinic or to their family doctor, they can fill out the information through the bot about so when the doctor is talking to them, they're not spending time collecting information that would have otherwise been done digitally. At the same time, you're starting to think about, hey, can I minimize the wait times within the waiting room so people are showing up the moment that they know that things are going to be prepared? How can I bring in a self-service aspect to this chatbot that improves the way that someone can interact with their healthcare providers or with the information that they need to make decisions on their own? So that's a very quick and short demo. Hopefully it kind of whets the appetite and gives you some things to think about. But in the interest of time, I do also want to start talking about some of the other topics, or rather Ramey is going to start talking about some of the other topics around computer vision and how some of these projects are structured and how we actually implement them.
Advait, I actually just have a quick question before we move on from the chatbot.
Sure.
So the keywords that the user is giving inside the dialog box, are you using those keywords to build the dictionary of the chatbot and then modeling those responses, or?
Right. So we're not training based off of just keywords. We're training off of full sentences. So it's starting to understand the meaning and sentiment of a message in a grammatical sense. There are keywords that we'll want to bring in there. So the example that I had given you was the the online billing system. Or another example in the case of the arthritis was RA. Those are key terminologies that we're building and adding into a dictionary so it can improve its understanding. Mm-hmm. When it's the combination of that intent, so the AI is understanding the intent of the question and seeing the entities that are relevant to that question, it can then determine the appropriate response. So whether it be dialogue or giving you a form or transferring you to human or showing you a map on how to navigate.
Cool. Thank you.
Yeah. Any other questions before Ramey gets started? All right. Well, kick it off.
All right. Thanks, Advait, and thanks, everyone. I'm going to talk to you guys today about visual recognition. My goal today is to give you a good understanding of it and give you our point of view on how it can provide value in the business context, and then walk you through a couple of examples of where we've applied visual recognition with the hopes of spurring some ideas on your end on how it can provide value for you at AHS. So the first thing I want to do is just put us all on the same page in terms of what visual recognition is. Sometimes, I do these workshops and I ask people, what comes to mind when somebody says visual recognition? And sometimes, I get, answers like, oh, maybe facial recognition. I know that's been in the news a lot lately. Sometimes I get these funny responses like somebody mentioning that there's an app called Not a Hot Dog, which is basically an app that you can download or where you upload a picture and it tells you whether it's a hot dog or not. And although these are examples of visual recognition, in our context, it's more about how do we leverage data science and machine learning, which Advait introduced, to extract visual features from images or video to provide business insight and value. And so you can think of that in terms of looking at a particular form and expediting the extraction of information from that, looking at a video and trying to see where some anomalies are being detected in a security type of situation, or you can look at maybe X-rays and trying to accelerate the analysis of X-rays with a high level of confidence to say there's something wrong here, there's something wrong here. Or you think of quality assurance inspections in industrial scenarios, so manufacturing or rail, which I'll talk about today, or otherwise, where you're trying to find defects and that sort of things. But to boil it down into a series of terms, and you may have heard this before, people saying a model, a visual recognition model or an AI model. What really this is a series of mathematical computations or operations that use artificial neural networks. So these are neural networks that kind of resemble how our brain works, that fire into those nodes, and typically you give them an input and they give you an output. From an object detection perspective, this is really just about locating where something is on an image, right? So think of a where's Waldo situation where you're looking at a big image and trying to locate where Waldo is. Classification is the categorization of objects into classes. So, in this case, it might be, Waldo's wearing a black shirt or a red shirt or whatever the neural network was trained to classify. In other instances, we do measurements. So this is kind of combining detection and classification at the same time, while also giving us an understanding of how big something is relatively on an image. So this helps in those manufacturing scenarios that I mentioned, or it could also help in medical scenarios where you're looking at certain imagery or rendering of a graph, or perhaps an X-ray or something of the sort, and to help people make or augment the decision-making process. Another thing that people tend to think about with visual recognition is optical character recognition, or OCR. This is about looking at an image, whether it's a picture or a form or a PDF or a document, and extracting text from those images. This could be looked at in a couple of ways. There's an easy way where it's a very nice high-quality image where things are very easy to extract out, and there are some off-the-shelf solutions that actually do that. Adobe, for example. But there could also be tough examples where you have historical data of documents that have been scanned perhaps multiple times, and the document is losing its quality, but you still want to expedite the processes associated with reading those documents. So that's OCR. Pipeline is essentially different combinations of what I just mentioned that are stitched together to give you a singular business-relevant output. So you might be doing a detection and then a classification and combining that with OCR and a measurement to give a particular user who's interested in knowing something exactly what they need to know. Now, why would businesses such as yourself want to consider visual recognition? The first business driver is saving time and money. So a lot of the time there are very time-consuming tasks that are undertaken by enterprise employees. I'm not sure why some of the text isn't showing there. Maybe that's just for me. But the idea is to optimize maintenance, inspection, or detection of these objects that I mentioned in a very consistent way. Another reason this brings value to business is it digitizes manual processes. So the idea here is you have many different types of employees doing many different things. Some of them are mundane, some of them are higher value. And the idea is to allow these employees to switch their focus away from the more mundane tasks and more towards the tasks at hand, which require higher specialized skills that we actually cannot automate or that are not good candidates for automation. And that really paints the picture for the organization of the future. The third business case driver is making business decisions based on data. So a lot of the time now we are talking to our clients about how do you make decisions that are based on real information that are observed in the field and less so based on human experience and word of mouth and that sort of stuff. So visual recognition brings value in that perspective because you can load a lot of these different documents or images and process those much faster and give you the decision points that you need to ultimately make a decision or make a business case for something that you're trying to present a case for in your organization. Last but not least, I've worked with clients who are using visual recognition to augment their existing capabilities and actually find new sources of revenue. This can take on many different forms, and it's probably the hardest one to think about for organizations, and it requires a little bit more maturity. But nonetheless, it's a very relevant business value that we're talking to with our clients when it comes to visual recognition. So I'll take a pause there and see if there's any questions before I move on to some of the examples where we've applied visual recognition.
Hi, Leslie here. I have a question. Can you hear me?
Yes, I can hear you, Leslie.
Yeah, so I understand that AI is capable of exhibiting or emulating emotion, and it is also capable of sensing emotion disposition through text, through audio, and images, which is what you just spoke about, computer vision. So my question to you is that enough to state that AI is capable of emotion in a holistic sense? If not, what's missing?
So maybe I'll answer that. There are a lot of different ways that we can do some sort of tone or emotion analysis. So as you mentioned, through images, it's about facial expression. Through text, it's really just more of a semantic thing, and typically works better with larger amounts of text. Voice-based emotion, I believe, is physically possible. I don't really know a whole lot of people who have done it well. And now, at the very end of the day, if you were to have an image and voice stream of a person and piece it all together, maybe you could really try to understand the emotion of what that person is in. But effectively, at the end of the day, it's a pattern-based system. So it will fail from time to time, and I would say it has no understanding of emotion at all. It is just looking for patterns that it's seen and and is trying to mimic it. So depending on your use case, you may want to be careful in the sense that you don't want to apply the emotion analysis because it could get it quite wrong, and in which case that could be poorly handled. And you may want to have a bit more of a neutral tone and make it very clear to the user that this is not a system that is supposed to mimic a human exactly.
Okay. My question is mainly based on, I saw several videos of Sophia the humanoid.
Yeah.
So to me, just listening to Sophia speak, it was Google search with the voice. The emotions were missing, which made it very clear that that is not human, although what's being said sounds like it is.
Right. So even with speech synthesis these days, they're starting to come up with AIs that can respond back, and its tonality is tweaked in a way that just sounds a little bit more empathetic. And I think we are getting to a place where AI can act and sound a little bit more empathetic than it has in the past, but by no means would I say it mimics anything close to human emotion today.
Yes, and then my last part is that voice response that we get from cell phone companies. I think I noticed it at first with Bell. That system is amazing. It sounds more human than everything else that I see out there in public. Do you have an idea what systems they use for their voice response when you call in for support?
So I don't have their exact contact center system. I think it used to be like a Genesis-based system. Now, the thing you have to be careful of is sometimes those voice systems are built out by actual recordings. Earlier in my career, I actually used to build IVRs, and we would actually go into a studio, we'd capture audio of all the different things that the bot could say, and we'd piece it together. So hopefully it sounded as human as possible. But more and more, there are speech synthesis APIs that are starting to get tonality and pitch really, really well. IBM has its own speech synthesis solutions, Nuance does, Google does, and we're all working towards that kind of effect and trying to achieve that kind of thing.
Yeah, so this is Jeff. So I'm in the contact center, and yet it's Genesis with a Nuance backend. But they do have a voice talent they use. They are not using a text-to-speech engine right now. Well, IBM, it's a real person, yeah. Or
Thank you very much. Yeah.
All right. So I want to talk to you about one of the key success stories that I have personally led here from IBM. It's work that we've done with a first-tier rail client, and their goal was to assess how visual recognition and AI technology can optimize the way that they manage their operations and how they do safety inspections, which are currently manually done today. But the sheer volume of trains that are going on their rail network makes it very difficult for them to meet the safety standards that they do want to meet and the type of excellence that they want to have there. So there's a number of use cases. There are actually 100 of them. There's a program that we're about to embark on very soon, and I'm going to show you a couple of examples. So this is a scenario where safety is at stake, and the client is trying to detect defective securements on their trains. So they're assessing many different aspects of the mechanical components that make up this engineering thing called the train and the train cars. And we were able to build these visual recognition models very quickly for them. And I'll show you how that is done in a demo. So I'm going to switch my screen. So now I have to go, where do I need to go, Advait?
To switch screen?
Yeah.
Yeah, so I think you have to go to just do desktop.
Okay.
Hopefully it renders well.
So are you seeing my screen now?
No, I'm just seeing the demo page still. Give it a second.
Yeah, you'll probably have to share the application.
Yeah, on the Mac, it doesn't give you an option for application, just desktop.
Okay. Is there a way that we could open the demo in a web browser and then share the web browser as an application?
We're trying to. It is on the web browser, right? Ramey?
Yeah, it is on our web browser.
Yeah, we're just trying to get it to actually show the web browser, because on a Mac, it doesn't give you the option for application. It says desktop.
So I actually have if I switch over to my presentation, there's a couple of images that I can show you that I think will do a good job of getting the point across and showing you the type of complexity that this technology can deal with. So I'll switch back to that. So are you still seeing my I can't zoom in, eh? Okay.
Okay, stop presenting, then present. Does that work? Yeah, now try sharing.
Are you able to see my screen now?
Not yet.
Not yet.
No.
If you're interested, I could probably share the screen on my computer, or I don't know if it's interactive, but that might be an option.
Do you want to send it to me?
Yeah, sure. I'll just send it to Advait, and he will share via his screen because he's done this before. Sorry about that, guys.
No problem.
All right. Now let's see if I can hear.
Oh, I guess you're no longer seeing this. Are you still seeing my screen by any chance, folks on the phone?
Not yet.
No. Not yet. Yeah. Do you want to share the application of your PowerPoint, and then we can? There you go. Yeah.
Okay. So you see the screen now?
There we go. We do.
Okay. Perfect. So in the interest of time, I'll just focus on the one that I think is the coolest in my view. And remember, again, there's 100 of these use cases. I'll just show you one for today. This is a view of a train coupler, right? So this is the mechanical mechanism that keeps trains together and prevents derailments and train detachments from happening. And the way it works is you see in this image here, there's a number of plates with bolts on top of them. Right, and these bolts is really what keeps that in place. So the visual recognition machine learning model that we built is first of all detecting where those plates are. So you see those big rectangles. There's 3 of them on this image where I've zoomed in, and then within that you're detecting the presence of these bolts. So these bolts take on many different shapes and sizes. And the idea is to detect whether the minimum number of bolts is present in these images, and accordingly classify that image as either defective or not. So if we look at the first, the top of the image there, you'll see that all the bolts are present. There's no problem with that plate. The second one, we've actually have to train it to ignore what looks like a missing bolt here, so that because it's outside of the carrier plate and it's rather classified or categorized as noise. And then at the bottom, you have an actual defective plate because there is a bolt that's missing here, and that's shown here with the red rectangle. So in this case, it would be a defective carrier plate, and by regulatory standard, this car would actually be required to be maintained at the closest possible inspection and maintenance point on the rail network. Here's another example of where the train coupler is effective. You've got on the top plate there's two bolts that are entirely missing, and this is an even more severe situation where they're required to take that car off of the line immediately just to be compliant with the regulatory standards. I'll show you another example that also interesting. This is called the brake piston example. So this is looking at the entire car from the bottom and trying to, first of all, detect where the brake piston is. So you can kind of tell this is more of an obscure type of image. And this is where we are detecting where the brake piston is. So it's found it there. Now it's marking it in red because it's engaged where it's not supposed to be engaged. So think about a situation where if you're driving your car, you definitely don't want your brakes engaged when you don't want them to be engaged. And here's also a good example of measurement where we're doing a ratio between the diameter of the brake piston and the length to which it's extended. So in this case, it's 1 to almost 4, and that meets the thresholds of a defective brake piston, and so it's marked accordingly. So in the interest of time, I'll just switch back to the presentation and talk to you about other applications of visual recognition. So I'll just get that back from Advait in a second here. Uploading again.
It's because we removed it. All right. So while we're waiting, any questions on that? So earlier on, I was talking about breast cancer detection from CT scans. You can kind of start to think about how the same image technology is, identifying very minute details for the sake of classification of issues, and that's how it's being utilized there in terms of radiology.
All right. If there's no questions. That for downstream processing. So think of any type of form or document that may be being filled out manually and somebody else has to read it and perhaps do data entry. This is the type of technology that can help automate that. Here's a slightly different one. This one is a real estate management client that was interested in understanding how the space in their facilities is being used. And so what we built here is a machine learning model that can detect humans from different objects and is tracking the movements in that public space to understand which areas are being used the most, where the highest traffic levels are, where do I need to make sure that there is consistent maintenance so that I can kind of prioritize the way that my maintenance crew is taking care of that area in order to optimize the user experience of that client's customers. So again, it's a detection, it's a classification problem, but utilized this time not on documents or images, but first of all using video rather than images, but also where it's a much more open space that people are using. I'm going to switch gears a little bit and talk to you for a couple of minutes on the IBM Innovation Garage. The IBM Innovation Garage is a new way that IBM is bringing innovation to its clients. It's a vehicle for bringing the depth and breadth of all IBM capabilities in visual recognition, in conversational AI, and even outside of AI to drive innovation with our clients. And so what it's really meant to do is it brings a core team of dedicated resources that help drive innovation, not for you, but with you, and trying to bring all these technologies together, allowing us to do hypothesis testing. It allows us to do very quick MVPs, and in a structured format allows us to go through many iterations as directed by a governance that is decided upon with IBM and that makes sense to our clients, to go through from an idea all the way to putting something on the market. And the reason we believe in this type of methodology or approach is because IBM has the IBM Institute of Business Value, where we interview and we gather a bunch of market data, and we ask our clients across different industries about innovation and how they view innovation. And 72% of the businesses that we are talking to are telling us that they are susceptible to digital disruption in the next 3 years. But with that said, only about 14% of them believe that they can act quickly enough to compete against that disruption. A lot of them see innovation as a great opportunity, but is also a very risky one. And so with this approach, which I'd be happy to spend a little bit more time with you in another opportunity, is a way to scale innovation in an effective way, bring about enterprise-grade solutions, but also managing the risk and the investment going into it. Finally, I want to give you a couple of suggested next steps. So I introduced the IBM Institute of Business Value, or IBV. There's many different ways that you can kind of continue to tap on and take advantage of the education and the material and the insight that's in there. So there's a website that we have. There's multiple reports that you can download, read, and share across your organization. And the second thing I would invite you to do is to continue the conversation with IBM. We collaborate with our clients of different industries. We bring all that knowledge, that business insight. We have research institutions. We have partnerships with universities and innovation hubs that can bring a lot of advantage when it comes to innovation and disruption. So, on behalf of the IBM team, I'd like you to consider an opportunity where we can meet again. We can talk about some of the challenges, the pain points, or the opportunities that you see are shaping up within your business. Help you understand the current state, the future state, and then work with you and collaborate on how we can get there. There is an annual IBM conference. Happens in San Francisco. It's taking place in May of 2020. And should you be interested, please do reach out to Rehan or Advait or myself, and we can talk about that and see how that can bring value to you as well.
Hey, Ramey, it's Cam Toner. I'm just going to jump in quickly. I apologize. Both Peter and I couldn't make the start of the meeting, but for the folks on the phone, I'm the client exec for IBM for healthcare and a large chunk of the public sector in Alberta. So just to echo the offer, if there's interest in Think or follow-on conversations to what you've heard today, you can also reach out to me if that's an easier approach. Jesse has my contact information and others in the group.
Thank you, Cam. Are there any questions or any comments or feedback? We're nearly at the top of the hour. I just want to make sure that if you do have something that we can use the time to answer.
I had a question there, if you don't mind, real quick. I wanted to know a bit more about the content analyzer. I understand it works with unstructured data like PDF documents and images and that sort of stuff. I suspect there's a like from a in the business world there's like vast majority of applications for something like this. Considering that there are still industries out there and businesses out there that are not fully digitized. I'm kind of curious as to how what have you guys seen in terms of traction on this analyzer and whether or not it's part of the Watson suite of products.
Yes, so it is part of the Watson suite, and it has a couple of different facets. One facet is the primary or more basic facet is to digitize documents based on certain, let's call them frameworks or topologies that have to do with a specific type of context. So there's a healthcare context, there's an engineering context, right? And so Content Analyzer is being used now across many different clients. It's a global offering that can be supplied with all of these documents that you want to analyze, and then provides an output in a way that can actually be processed very easily downstream for different business functions. So that's the primary aspect of it. The second aspect of it is that it is exposed or can be exposed to the different type of Watson services or AI services that can be tagged on to it to do things like, for example, if you're looking at text analytics, understanding tone, understanding I think somebody from your side was mentioning emotions and that sort of services, but also very importantly, understanding intents, understanding content that can be used for responding to that document. So think of RFP type of situations where you're trying to extract key requirements out of large documents. It can also be used in situations where you're trying to read documents containing tables and whatnot, and presenting and aggregating multiple tables and the data within in a summarized, concise, and easy to understand manner. So a major offering from IBM has the ability to be flexible to cater to different needs. It's very business user friendly, so even our clients are using it themselves to do that extraction and that processing, and it can bring value in many different ways. So I'm happy to do another demo of that or facilitate that for you if you're interested.
Thank you for that. Just to follow up on that, do you have to tweak the analyzer or retrain it for every vertical that that IBM gets engaged with?
I wouldn't call it training. I think it's really a configuration and creation of that context-specific framework. So there are certain concepts that are relevant in engineering, for example, that are not in healthcare, and so you would just need to introduce the idea of patient, and that's something that you can actually do in minutes. So it's not a very onerous, training type of task that would need to be done in order to configure it to a particular client scenario or industry.
Cool, thank you.
That's here. We're at the top of the hour here, and I'm sure people will have the next meeting. So I want to take this time to thank IBM so much for the presentation. It was extremely interesting, and if anyone has any questions for IBM, their email addresses are in the chat window, and look forward to meeting you at the next AI CoP meeting.
Thank you very much for your time and giving us the opportunity.
Thank you, guys.
All right, cheers.
Okay, thanks all.
Thanks a lot.
Bye.